The objective here is to find the exact value of arc cosine of 1. In other words, find the inverse cosine of 1. Now, another way that you can write this is cosine of what value is equal to 1. And the reason we can write it this way is because if you recall normal functions, for example, let's say you have f of x and the inverse of f of x, well, which is the inverse of f of x, right? In f of x, in your regular function, if you put in x, you're going to get a y value, right? In the inverse of that function, it basically just takes in your output, your y, and returns to you your x. So same thing over here. We're kind of working backwards at this time, but cosine of x, if you put in an x, right, you get out a y, right? But then the inverse, what it does, it takes the y and gives you back the x. And so really what we're looking at over here is we're putting in an x and we're taking out a y, and the inverse is putting in the y and outputting the x. And so what we're really looking for is this x value. So first of all, one thing you have to note, and I always put these in stars, when they ask you if cosine of a point, they're just asking, hey, what's the x value? And number two, the points of the unit circle. So I would memorize those. So this one is 0, 1. Here we have 1, 0, 0, negative 1. And then here we have negative 1, 0. We're really looking for the x value, right, when it is 1. And that's over here, which is the only point that has it. But now we can't really say that, okay, this is the point and this is 0, so it's 0. No, we have to verify that this point is actually on the inverse function of cosine, right? And we do that by explaining a little concept to you here. So when you look at cosine of x, which is your red line over here, and then the inverse is this line over here, you can tell that they're a little odd, right? The domain of cosine of x is from negative infinity to infinity, right? Because you can choose any x values on the x-axis, any of them, literally any of them, right? But then the range, you can notice that it's from negative 1 all the way to 1, right? So it's never, any y value is never going to go above this line, nor is it ever going to go below this line, right? So the range is from negative 1 to 1. So anytime you put in an x, which can be from negative infinity to infinity, it's only ever going to give you a y value that's between negative 1 and 1. And so we talked about this, right? The inverse of that function takes in the y as their x values and then outputs the original values, right? And so it just happens that because every single y value in the original function can only be between negative 1 and 1, that just causes the domain, right, of the inverse of cosine to also be between negative 1 and 1, right? So any x value, right, is always going to just be between negative 1 and 1. So it's never going to be here, it's never going to be here, because cosine of x never gives us any values that are outside of negative 1 or greater than 1, right? So that's the idea. And so just because it has to satisfy this concept of inverse functions, it just happens to be that the range starts at 0 and then ends at pi, right? Which is over here. This is 3.14, whatever. Well, it's actually 3, but it's right about there, right? So that's the range from 0 to pi. And using this information over here, we can answer this question over here. We know that this is our point, but does it satisfy, right? Does it lie on arc cosine, on this function? Does this point actually lie on this function, right? That's the question that we are trying to answer, okay? And we can figure that out by looking at its x and y values. We can ask it, okay, well, does the x satisfy the domain? Well, okay, the domain, again, is from negative 1 to 1, right, for inverse cosine. The range is from 0 to pi, right? Is 1 within the domain? Yes, because it is bracketed, so it's equal to, correct. So the x value satisfies the domain of this function. Now 0. Is 0 within the range, right, because it's y? Yes, It's included. And so therefore, both of these values satisfy this function, and therefore it lies in the function. And we can actually see that it does lie in the function. If we go look at 1 over here, so 1 should be about right here. It's right there. 1, 0. It lies in the function of arc cosine, aka the inverse of cosine. Now as to what the exact value is, it's 0, because when you put in 0 here, you're getting 1. Cosine of 0 is 1, because you're looking at the x value. Cosine is the x value. So when you look at cosine of 0, it's 1.